hi, hello everyone, welcome to this particular video. We'll be talking about Python interview questions of data engineering, and it will be very much focused like proper live scenarios. We'll be talking about real interview questions, and I'll be also explaining you. I have my pen tablet with me, so I'll be explaining you with all of my efforts, all of my experience. Other than that, I have already made many videos on data engineering. That all things are already there. Other than that, it will be proper. I have spent a lot of time creating these kind of presentations that I'll be showcasing you. So please give a like button and comment down. So let's start. So as you can see on my screen here, this is the first one. Basically that is the first slide that will talk about the Python data engineering questions. Okay, that we'll be talking about one by one, and it will be deep answer will be there. I'll be telling about the real scenarios, real interview question, real context I'll be giving you, so that you have all the idea about the things and you are aware about the things what exactly can happen in the live scenarios also. Okay, so let's start with the first one. And what exactly, when you are going for the interview, let me give you that mindset also, because I take many interviews for data engineering and data roles. So basically I have that idea ki what exactly I want to test, or an interviewer point of view, what exactly needs to be tested. First thing is memory thinking. It is not about how exactly you will write the code, or how exactly one point by point you will line by line how exactly what all things will be done. No, it is more of what is your memory thinking, like how we will handle larger data sets without crashing your system. Second thing is scalability. When suppose you are writing a code, or you are giving a solution, or you are talking about one of the answers, so how exactly it can scale if the data also increases and or the user loads increases. Okay, fault tolerance. If you have written a sort of code, 5 lines of code, so what is the fault tolerance of it? If anything fails in between, what will be happen? If you build some kind of pipeline, what will be the recovery, how it can recover gracefully from the failures and interruptions. Next thing is your production safety. So production safety also we'll be talking about. So because it is very very important, we need to think about all type of aspects whenever you are going for any type of data engineering roles, when you will be working on the live scenarios. Okay, so that is also very very important. So let's talk about the first one. That is the first question: why is Python not suitable? Okay, it is a this kind of question. When it will come to you, you will be very much confused ki what he is asking or what he is talking about. Okay, so why is the Python not suitable for large scale data processing? We have talked about so much about Python ki Python is so widely used, but why exactly it is not suitable, or why exactly we pair up with different kind of frameworks or different kind of technology or APIs with Python, so that it can process large amount of data sets. So first of all, whenever we talk about Python is single threaded. What is the core limitations of this thing? That is, it runs on a single machine with limited resources. When what does it mean? Python by default is single threaded. Okay, next thing is global interpreter lock is there, like it blocks the true whenever we talk about interpreter, because Python is interpreter first language. There is no compiler, it is interpreted language. Okay, so what will happen is that is the block, whenever you talk about the code of the block or global interpreter lock is applied, that applies because of that the CPU, whatever your CPU is there, if it blocks your parallelism also. It cannot work on multiple tasks at the same time. That is a limitation, core limitation of this particular technology. Next thing is it is not designed for distributed computer engine. Okay, whenever we talk about Python, we talk about different kind of ecosystems, like ecosystem or technology like Hadoop, PySpark, Apache Spark, or Iceberg. These kind of technologies we talk about, right? Why we talk about those kind of things? Because Python doesn't support distributed compute engine. Okay, it is not designed for that. Next thing, it is memory bound for whenever you talk about large data sets, because it will exceed your random access memory, that is RAM. It will exceed and it will be out of memory errors. So that is also very very important to understand. So Python is good. Python is a very great coordination tool. It is not a processing engine for the big data loads. Whenever we talk about big data loads, so we'll talk more about Apache Spark or distributed systems, Hadoop, these kind of technology. We will not talk about what Python can do. We have APIs to talk, like API of PySpark is an API that we use to talk to Python, PySpark, like Apache Spark, so that distributed systems can be done. It is a distributed engine, so we can process that big data, giving that distributed this thing. But directly Python cannot afford it, or it doesn't supports it. Okay, so that was the first thing. Next thing is basically, next question is how data engineers actually use Python. Okay, whenever we talk about Python, we need to understand about these things also. That is API ingestions we talk about file movements, one place to another place, orchestration of the things we talk about. Then is a workflow control and scheduling, that is called as orchestration only. Ki basically, suppose one of the workflow is there having different tasks, or one for workflow is dependent on 5 different workflows. So how exactly your workflow will run, when it will run, what will be the scheduling of it, those kind of things also matter. Next thing is validation and data quality checks. Data quality checks, because see, whenever you build a kind of a pipeline or build a kind of a system, it is just not, it doesn't matter ki from one place to another place your data will go. No, you have to also figure out that exactly what will be your data quality checks has been applied or not applied. That is also very important. Then heavy compute happens in SQL engines. Then we talk about Apache Spark for distributed systems. We talk about data warehousing for with Snowflake is there, BigQuery is there, Redshift is there, so many data warehouses are there. So Python is great for coordination. Python coordinates the logic, compute runs the whole data hive. So that we need to understand, that is very important to understand, that Python is what it is. Python, the computes, different kind of computes are present to handle different kind of workloads and all. So there Python doesn't help you, it helps you coordinate the things. Okay, because the APIs are written in Python, it is Python friendly, so we can talk with those things with Python. So that is the advantage of it. Next thing, suppose you are working with, second question is, suppose you are working with 50 to 100 GB CSV file, and how exactly, what exact steps you will be doing so that it doesn't crashes. You want to load that CSV, 50 to 100 GB of CSV, comma separated values files you have to process. So basically what you will be doing so that it doesn't crash, what will be that thing? That is the beginner, a junior engineer, what they will do, they will say, I will use I will use read CSV to load everything into the memory and at once. But what is the problem with this? It will do, read CSV, what it does, it loads whatever is there to your memory at once. It will be not generating the things one by one. It will be doing loading. If you have 100 GB of data, it will be loading 100 GB of data at once in your system. So that can happen, your crashes can happen, out of memory errors can come. Okay, so we don't use that. Correct engineering approach will be chunk-based load, like partition load we'll be doing, or we'll be doing stream processing that reads the data in a manageable partitions one by one. Smaller chunk of data will be read one by one. That is a better approach. Or you can do streaming processing, you can do batch processing, these kind of system, these kind of things you can use. Okay, that is very important. Why this matters is basically memory save stable, because see, the data can increase, scalability issues can be there if you don't use these kind of thought process or preventions or architecture design. You don't think of these things, so that will be a problem. So that is how a senior data engineering roles or data architect roles comes into the place. They have to figure out these things, they have to figure out these particular things. So it is memory safe firstly, unstable underload will be there, restarting of the restart friendly will be there, and suppose it fails in between, like you are loading say 100 partition and 200 partition are there, so it failed at 100 partition. What will happen if you resume from there, if you rerun it, you can apply that logic of resume from there after, then it will load again 100, 100, 102. If you don't apply this thing, what will happen? It will start again from 0. 100 partition were loaded, again from 0 it will start again at 100, it can fail. Okay, it can happen. So that will be a very poor design to do. Okay, that is also matters. Next thing is chunk-based load, chunk-based processing. What is a chunk-based processing? So there are many things, like basically there are functions to it. You can load, it accepts your read CSV, accepts a chunk size. Basically you can give a chunk size, and as per that it can transform and write your data. That is how it works. In Pandas also it is available. In Spark also it is available. Spark better to directly use a distributed system, and directly it is inbuilt because Spark is a distributed data processing engine. Okay, so it applies initialize those things in the backend. No need to worry about those things. Okay, but in Pandas you have to, because Pandas is a single threaded technology. One by one it will do the things. So you have to figure out by like that. So why this works? Constant memory usage, regardless of your file size, one by one, like it will be dividing your data into 500 chunks, and then it will be it will not fail. It will partial failure isolations will be there. If anything fail, you know where exactly in which chunk it is failing. Next thing, production safe pattern will be there, so it will be very easy to figure out. So this was it about the things. But see, if you want to learn about, like I have been teaching about these things in my boot camps, so if you want to learn about everything from scratch, from zero, so definitely we have an end-to-end data engineering bootcamp, DataX bootcamp. Link and the coupon code is in there in the description. If you want to ask some question, we already have the support number of the WhatsApp also. Directly go on that number and directly you can ask the questions. Okay, you can text on that. So we have all these technology. We have talked about Python from the scratch, data modeling from the scratch, we have Hadoop from the scratch, Snowflake is there, Spark is there, Pandas is there, GCP we have done end-to-end project. We have used ADF also, Azure Data Factory, Azure Databricks we have used end-to-end. We have SQL end-to-end, MySQL is there, then end-to-end SQL, about joins, about CTEs, about everything about SQL is there end-to-end. And we have also integrated Gen AI, generative AI also in our this thing, so definitely it will help you. And all the whole bootcamp is very much focused on your job focused, interview focused things are there. So definitely it will help you. And so many success stories we have. People have done from 0 to 4 offers in data engineering, 4 offers to data engineering from non-data background, from 0. Okay, so definitely you can also do. If you want to get enrolled into this, if you want to know about more about this, so links are in there, all the links are there in the description. Use the coupon code, right away you can enroll. Definitely for YouTube we already have YouTube focused code already, you can use that. Next question is basically that in list, people can ask you in the interviews, what is the difference between list generator and iterators? What is the difference? Definitely. So on an interview point of view, on a data engineering point of view, these 3 things are very, very important. Whenever we talk about list, majorly we don't use list. Okay, because what is the problem with the list? That is, it loads whatever will be there, whatever. If you want to assign 50 GBs of the file in a list, it will automatically take all the 50 GB at once and load it into the memory. That is a disadvantage of using a list. So that's why what it says, list says ki load everything into the memory upfront you have to load everything, and it is dangerous. It is definitely very dangerous for big data. They can exhaust whatever available RAM will be there, whatever available memory will be there, that will be exhausted. That's why we don't use list if we have to load major like huge amount of data or big data. Whenever we are talking about, we majorly use generators. What generator says, generators are basically called as lazy evaluation method, and it is very great for big data processing, because lazy evaluation is one of the memory efficient thing to do. Okay, so lazy evaluation with memory efficient generates the value on the fly without storing everything on the fly. Whenever it will be required, at that time it will generate the things. Iterators are something that is, it is controlled sequential access to the data and provides consistent, like for loop, these kind of looping systems, or whenever iterators will be talking about, that is what we talk about. That is, it provides a consistent interface for traversing the collections of the data. So this also is, these two things are very, very important. And whenever people will ask you in the interviews why list is not preferred in big data, you can directly respond like this. It will be a very good impression. It will be giving the interviewer also, and it will be setting a very good impression also. So that is how you have to answer. Next thing, generator example, if we talk about yield, you might have heard about. Whenever we load a data at once, it will not load everything at once. This is iterator, and this is called a yield, is called a generator. So it will be generating the content of the file also at the point of when it is required. It will be not loading all the file at once. If you might have used here a list in other than generator, so that will be a problem, because the file size can be 100 GB also, 500 GB also, 600 GB also, and it will fail with out of memory errors. Okay, so we don't do that. So it is perfect for whenever we use generators. It is very perfect for logs and APIs. It handles continuous stream of data without memory buildup. It will be not doing, because whenever the data will be required, at that time only it will be loading the things. Next thing is it prevents the memory spikes. Whenever the the memory spikes are happening, at that point it maintains the constant like memory footprint. That is pipeline friendly. We can use directly in your pipeline code, and it does chain operations very efficiently because it generates whenever it is required, data is required. So generator lets Python to behave like a streaming engine. Okay, that is why generators are more important to understand and to like answer like this in the interviews. Okay, next question is, whenever we talk about Python or pipeline, so people will ask you how we can handle the problems or fault whatever is coming, how we can handle the risk of failures. Okay, so that is called as fault tolerance. Okay, so fault tolerance means whenever anything fails, how cleanly from the anything recovers cleanly from the interruptions or failures. Next thing is how when it fails safely without data corruption in between. Suppose any data corruption is happening, how you can minimize it and how you can maximize that particular data safety. Okay, data corruptions are not there. How, suppose at a checkpoint, suppose your data is of 100 GB, you are processing, and here it failed. Okay, how you can set up something so that whenever you rerun it, it can start from this particular point. It is a checkpoint here. Now it has to start from this particular point. Okay, now it has to start from this particular point. That is called as checkpointing. Successful checkpointing you have to do. Next thing is basically retry logic. You have to, what all things you can do. First thing, you have to apply retry logic. Whenever it fails, automatically exponential backoffs will be there and directly it start from there. Next thing is idempotent rights. Whenever we talk about idempotent rights, idempotent means basically, suppose you run a pipeline one time, okay, it gives a result. Another time you run a pipeline, it should give another time the same result. Third time, another time the same result. How many times you run that pipeline, it should give the same result. That thing ensures same operation can run multiple times safely. So that's why we call it as idempotent rights. Okay, that is very important. Third thing is your checkpoints. You have to save your progress every time. You have to set up a code like that so that it updates your checkpointing, partitioning properly. You have to process, or you have to think of a code like that. That is how it matters. Next thing is comprehensive logging. Okay, it tracks your failures and debugs the production issues. Very important to understand. Okay. Next point is basically, right now we were talking about fault tolerance. So there are many patterns to it. Okay, pipeline, whenever it fails, there should be a backoff mechanism. There should be a retry attempt. Then only it should success. There can be a failure. Definitely, if you are running a pipeline, you have to think about if it fails, what will happen, where I'll log my efforts, where I'll log my things, so that I can resume the things from there. Maybe 100 GBs of the file I'm processing. I'll not process the full GB again. If it is failing at 90 GB, I'll not process the 90 GB again and then fail again. No, I will only resume it for next 10 GBs only. That is how you have to think about that. Okay, so you have to try catch the things. Like this is how you have to try catch. You have to log the things and all. Okay, that is how. So basically in the production reality also, status is tracked in the metadata. We create small metadata tables in the project. In the DataX Bootcamp, whenever we have made project, we have made these kind of metadata tables, so that to showcase how exactly productions level these things are done. And from that, so many people have got benefit. Definitely you can also learn from there. Other than that, job resumes from the checkpoints. It doesn't restart, it resumes. That is what you have to think like an engineer. You have to resume the things, not restart the things. Next thing is that is alert is sent on the call engineer. Whenever a failure is happening, you have to send an alert. That is very important. Next thing, retry the counts and delayed are configured. Like any delays are there, any retries, you have to count the things. Okay, that is how it happens. Fifth question is that is basically what is idempotent and why it is critical. We have talked about idempotent is very important to understand, because in the live scenarios, or maybe you have not heard about it also before, because it is important. These terms, whenever we run, same input gives the same output. It's whenever I am giving 10 types of input, 10 types of output should be generated, and that one type of output should be equal to that one type of input every time. Output input should be, if I am giving some input, it should generate or expected type of result should be there. That is called as idempotent. That term is called as idempotent. Okay, so when we are running the pipeline multiple times, it produces the same final results regardless of how many times you execute the things. Okay, that is why it matters also. That why it matters, because whenever you retries, because see, in between it can fail, after one step it can fail, after two step it can fail, you have to set up retry logic, right? So retries happen in the production environment, also in the development, QA, pre-prod, all type of environments that happens. So exactly you have to figure out ki basically if I have to run those things again, if I resume that thing again, so it should give me same kind of result. Job fails when you need to rerun the things. Schedulers may trigger duplicate runs can be there, like suppose you are running something manually, scheduler can trigger at the same time, and what can happen, it can load duplicate data also, that can also happen. So I have to figure out that also. And network issues, partial completions can be there, because of that also that all like kind of problems can be there. So idempotency handles these kind of things. So without, whenever idempotency is not there, it duplicate your data and populates like pollutes your data set. Basically your loads are polluted, your duplicate data is coming in. So that all things are problems. Okay, so we have to figure out those things also. Wrong matrices, like your dashboards will be wrong, your matrices will be wrong, eventually business impacts will be there, broken dashboards will be there, like to the stakeholders, they will be having trust issues also if they will not see the correct data. So these kind of data integrity problems can be there. That's why idempotency is very, very important. A non-idempotent pipeline is a production risk that will eventually cause the data quality issues. That is how you have to think of the systems, and that is how you have to think of the things. Okay, so that is how it matters. Next thing, sixth question can be, what is the difference between multi-threading and multiprocessing? Multi-threading and multiprocessing, as the diagram here shows, multi-threading is something you have one processing can do parallelly same kind of task into different chunks. I have A work to do, or I have to build a building. Okay, I can give I can assign 5 workers to it. They can work on the same building and complete the task. I can assign 10 workers also, and they can build on the same task. Multiprocessing is, I have 1 building, 2 building, 3 buildings. Okay, they can work on parallelly, like 5 workers are there, they can work on three different tasks parallelly. That is called as multi-process. Different kind of process they can work. Okay, that is the difference between multiprocessing and multi-threading. In Python, whenever we talk about multi-threading, it is best for input-output bound operation, like Python API calls you are doing, file reads you are doing, database queries you are doing, and limitations are locks. Locks is a very, very big limitation. Whenever you do multi-threading, you want to write something or read something at the same time from any kind of database or query you want to do. So lockings are there. So true parallelism cannot happen. So that is a problem. Whenever you will work on a system, so real world scenarios you will be doing, or whenever projects you will be making, like project means live projects also you will be making, or self-based production projects you will be making by your learnings only. So because we have done these kind of things already in the DataX bootcamp. Okay, so people from there, they understand these kind of things, but definitely a good background is needed to understand this. So what is, like, how GIL, your global how locking is happening, and how true parallelism is getting blocked. For that understanding, you need to have that particular understanding of those things, but still improves IO throughout the significantly. Definitely it helps you in that. Multiprocessing is something that is in CPU bound task. Whenever you are doing like data transformations you are doing, complex calculations you are doing, model training you are doing, because different kind of processes are there. Okay, so at that time you can use multiprocessing. Advantage is true parallelism is there definitely, because CPU cores are different also. Okay, so multiprocessing will be there, multiprocessing, and it bypasses your GIL, the lock system, the locks that we are talking about, that it will pass completely. So it is better, but definitely thread pools are there to use in the Python. Different kind of like thread pool is one of the concept that we can talk about, or we definitely can have in different kind of classes, or we can understand, because in the this thing, it is very, very important. Whenever you talk about parallelism, that thing is important. So global interpreter lock blocks the CPU this thing whenever we talk about threads, multi-threading whenever we talk about. Okay, that is also a thing. Let's talk about the next question. That is the seventh one. Definitely it will be a detailed video, as I have talked about, because there are many inputs to be given also. It is not like I will talk about this one point I'll be telling you and that is it. No, I'll be giving you proper insights so that you understand the thing also. That is also important. So definitely whenever you are talking, whenever you are secrets are something like password, server password, server DNS settings, or usernames, user passwords, or API keys. These are the secrets. You cannot expose this into your pipelines or code, hard coded. You cannot do those kind of things. What you should not do whenever you are talking about these kind of password or confidential information, confidential code. So at that point, hard coding the secrets in the source code, you should not hard code the thing. You should not store the things into your Git credential repositories. You should not do that in the code directly. You should not pass that thing, and secret should be not passed as a plain text. Directly you can read that. No, it should not be done like that, and that is not a best practice. Your pipeline will not be approved. Maybe DevOps will set that kind of compliance, so it will not go to your PRs also. It will fail in your compliance PR only. Okay, that kind of things can happen. Log sensitive information you should not give. Okay, next thing is, what is a best practice? You should use different kind of variables, local development. Whenever you are doing development, at that time only get a best practice to use different kind of environment variables. Next thing is cloud secret managers are there, like AWS secret manager is there, Azure Key Vault is there. These kind of secret managers are there, where you can pass your passwords, keep there, and directly from the variables you can fetch that. Okay, that is can be there. Runtime injection can be there from the orchestration tool, directly from the global parameter directly you are injecting, and it will be platform dependent also. Platform means your this thing dependent also. It can be encrypted keys you have to pass. So that is a security, this thing. It is a best practice to do like that. Next thing is data quality. Whenever we talk about data quality is something, suppose you made a pipeline from A point to B point, your data is there, different kind of sources were there, and you have processed everything is processed, and on the B system a data warehouse is there, directly your data is there. But how you will rectify whenever you are loading the things, everything, your data integrity is maintained and the correctness of data is there. Business correctness of data is there. The data quality is maintained. You are not having null values in that. You are not having null values in not null column. Order ID should not be null. Okay? And you are getting order ID is null and many rows. So that should not happen. That is called as a data. There can be different kind of business rules that has to be applied, and that is how we think of data quality. Okay, data quality is something. Common checks are null value detection checks. Next thing is schema validation. Every time you have to, expected structure should be there every time. There should be range checks, numerical field. Suppose the value should not exceed 500, or it should be in between 50 rupees. I am selling a product that is over, all the products are above 50 and all the products are not greater than 500 rupees. So that particular range should be maintained, all the products. So that is called as this thing. Duplicate record identification, row count reconciliations. Okay, referential integrity across the data sets. So these kind of checks you have to apply. That is called as data quality issues. So validation failures you have to alert triggers you have to do those things, like you have to notify those things. Audit log should be there. Any failures are happening, there should be a proper logging system where you have to log. It can be a table, it can be a logs, it can be a report. Anywhere you have to report those things so that any engineer can come and they can work on those things directly. Okay, that is called as data quality issues. Data quality frameworks also we talk about. In Databricks we have many open systems, open source libraries that you can use directly, import it to apply these kind of data quality checks. Okay, these kind of things are also there. So we have to talk about that thing also. So how Python pipelines are scheduled in production. Whenever we talk about Python pipelines, so automatically, manually, we don't run the things. Definitely it has to be scheduled. So we need orchestration tools. There are different kind of orchestration tool. More or less, there are different, just the interface things are, the major concepts will be same, but how they work and how exactly we orchestrate the thing, the functionality, the UI can be different. First one is very famous that we talk about, that is Apache Airflow. Then there are for every cloud there are different kind of schedulers, like Google Cloud has its own scheduler, Azure Functions are there, then ADF is also one of the orchestration tool. It is not a scheduler, you can also schedule it, we can also orchestrate via that. We have Cloud Composer in the GCP, we have Event Bridge in AWS. Definitely these kind of systems are there for scheduling your things. Other than that, orchestration benefits are there, automatic retries on failure. But whenever you are using different kind of orchestration tool, you will be getting these kind of benefits, that is task dependency will be there. You can set up task dependency, that I want this task to run after this task succeeds, or if this is failing, this has to run. These kind of rules you can set in your orchestration tools, that is called as different kind of orchestration tools are there, like Databricks workflows are there, Apache Airflow is there, Azure Data Factory is there. These kind of orchestration tool, Google Cloud Composer is there. These kind of things are there where you can compose your things. Next question is, what is Python versus SQL? Whenever we when we should should use which kind of tool, when you should use Python, when you should use SQL. So different kind of tools have different kind of benefits. Definitely, what is the rule of a thumb whenever you are talking about like this thing, small logic, you should use Python directly. API call is there, file operation is there, orchestration is there, any kind of automations you have to do, you have to use Python. Okay. Next thing, whenever we talk about SQL, large transformations are there. At that point, SQL or Spark you have to use. Okay, SQL or Spark joins, aggregation, filtering, complex calculations you are doing on a large data set. At that point you should use what? You should use SQL or Spark, because they will give you different kind of functionalities. At that point you have to use those things. That's why it is important. Why it matters? Database and distributed systems are optimized for data processing with query planner, indexes, parallel execution. But what we talked about Python previously in the previous slides, that is Python is not designed for large scale data transformation. So at that point, when you will be using Python directly, it will slow down because it is a single threaded system. It will slow down your process, or you have to use different kind of multi-threading, multi-processing, these kind of concepts directly. So it doesn't support those kind of things. Okay, that is also important. Next thing, whenever we talk about like this one, that is key engineering principle. There are many key engineering principles also. Definitely you should learn. That is memory awareness. Chunking we talked about. We talked about query, what we say, process of large files. Whenever we talk about without exhausting your main system, if you are having 50 GB of RAM or 5 GB of RAM, you have to keep this into the mind. You have 5 GB of RAM and you cannot load directly 100 GB of file at one go. You have to use different kind of systems or different kind of distributed things so that it can process it. Fault tolerance is very important. Right key tools you have to process. Then production readiness should be there. You should always, whenever you are talking about different kind of solution, one thing has to be in the mind, whether I can scale it and whether it can go to my production and it can handle those kind of things. So that is how we have to process the thing. So these are the things. There are different kind of interview preparation strategies also. Course concepts has to be every time ready. You have to practice, code it. Whenever you will code the things, then only you will be understanding the concepts. And if you want to learn everything from the scratch, from the zero, I have already covered everything from very zero, and we have so many success stories from this data engineering bootcamp, DataX bootcamp. Directly you can get enrolled. You can learn all these technology from the scratch, from the zero, with proper production ready projects. Live projects are there, end-to-end projects are there, and definitely you will be getting so much of benefits, so much of insights. So this was all about the things, and this was all about the scenarios. Thank you so much for watching this particular video. If you liked it, definitely please leave a comment. Any doubts are there, leave a comment. And if you want to get enrolled into the DataX bootcamp, you want to learn about the things from end to end, from the zero, from the scratch, and you want to get ready a high paying data engineering job, definitely links are in the description. Use that, use the coupon code and get benefit of it. Thank you so much. Bye bye. See you.